Okay, so here R represents the base of that number system. So if you are dealing with base 10, that is decimal number, it will be called as the tens complement. And if you are dealing with binary number where base is equal to 2, it will be called as the 2's complement. Okay, so here R specifies the base. So if you are given a number n in base R, so R can be anything. R can be base 10, 8, hexadecimal 16 or 2 or anything. So depending upon the base system, it will be called. The name will change. So if we are given a number n, suppose we are given a number n can be any number in base R, okay, having n, small n digits, then the R's complement of n will be given by r to the power n minus that number. Clear? So for decimal number, r is equal to 10. So it will be called as the tens complement. So the tens complement of n will be given by 10 to the power, the base to the power n. This small n is the number of digits. Okay, 10 to the power n minus that number.
Number.
Okay. So this is for base 10, that is decimal number. So
Decimal.
for number with base or r equals to 10, that is tens complement, r's complement is called tens complement, and it will be given by 10 to the power n minus 1. Okay, for example, let's say if this n, capital N, the number is 546700. How many digits are there? How many digits are there? 1, 2,
6.
3, 4, 5, 6. Okay, so there are 6 digits. So 10 to the power 6 means there will be 6 zeros. So 1, 2, 3, 4, 5, 6. Okay, 6 zeros, 10 to the power 6, okay, minus the number. So this will give the tens complement of this number. Understood? How do you find the tens complement of a number?
Okay, ma'am.
Okay.
Yes,
Now
ma'am.
I yeah. So now I would like to mention here is that this small n, capital small n. Okay, the number of digits. You should count only the digits on the non-fractional part. That is the number of digits before the decimal point. Clear? Yes or no?
Yes, ma'am. Hello.
See here. So the formula is 10 to the power n minus n. Okay. So this will be power. Okay, so here if n equals to 9856, let's say, then tens complement of n. Okay, so complement tens complement of this n, that is 9856, will be given by what? How many digits are there? 4. So 4 zeros will be there minus 9856. So this will give the tens complement of this number n. Clear? Understood so
Okay,
far?
ma'am. Yes, ma'am.
Now, if I say n equals to 123 dot decimal point 45, so what will be the small value of n out here? Here in this case, n equals to 4. Clear? So up to here we are done. Now for this question, n equals to 123.45. So what is will be the small value of n? Tell me.
Mm,
What will be the value of small n? Tell me. N is the number of digits. Small n is the number of digits. Yes, Gulshan Pratap, Pransul, reply. Ansul, what is the value of n, small n?
37, ma'am.
What will be the value of n, small n? Just tell me whether it can be right or wrong. At least respond. Okay, if I call and if you people do not respond, okay, I will not give attendance. Gulshan, Pransula, can you hear me?
Yes, ma'am.
Then, yes, yes, Ansul, what does it mean 37? What is the value of n means small value of n is the number of digits. How many digits are there? In the previous one, 9856, you have four digits.
Three.
9856, right? So you have got
Ma'am,
four
three.
Yes,
digits.
ma'am.
Yes.
Ma'am, three.
Who is that? Three is replying. Pransul or who? Who is it? Pransul, is it you?
Three.
The answer three is correct. I just asked who replied the question. Why are you not responding? Who answered three?
Ma'am Pransul.
Pransul. So, Pransul, why are you being quiet? You should have said, ma'am, I was the one. Okay, so here I'm telling you the answer will be 3 and not 5. Clear? So if it is 5, your answer will be wrong. So the value of n, how much you are taking, it is important. Important means this is what will decide. So now the value of n will be what? The complement of n will be 10 to the power minus 3 means 000 1000
Zero.
minus 1 2
One, two, three.
3.
3.45. So whatever the result you get, that will be the tens complement. Clear?
Yes, ma'am.
Now, if
Yes.
the next question is, what if the value of n equals to 0.985? Now find a tens complement of this number. Right now, calculate it. What will be the answer? Just tell me right now.
One.
What will be the small value of n?
One.
What is 1? What is 1? What is the small value of n? First reply. What is the small value of n out here? Tell me, 1 is wrong. If one whoever is replying, if it is about the small value of n is wrong.
Ma'am 0.
Yes,
0.
0. Okay, because 0 you are just putting it out here. If you have write
Yes, ma'am.
1 0 something like this, then you could have said 2. 0, if a number starts with a 0, okay, so this is not counted. Clear? So it will be 0. So
Okay,
10,
ma'am.
yeah, yeah. So now 10 to the power 0. What will be 10 to the power 0? What is 10 to the power 0? Any number to the power 0 is 1.
Ma'am. Ma'am.
Yeah,
1.
right. So 1
Hmm.
minus 0.985. This will be the tens complement of this n. Clear?
अच्छा से निकलेगा.
Yes, ma'am.
Understood or not?
Yes, ma'am. Yes.
Okay, so this is about tens complement. Okay, now can you see this? Tens complement I have you understood. Now coming to two's complement. So if in that formula, if you represent if the base of the number system is two is binary, that is two, okay, then it will be called as the two's complement. Understood?
Yes, ma'am.
So r's complement is a 2's complement, and a 2's complement of that n will be given by the same formula, except since the value of r out here is 2, it will be 2 to the power n minus n. Clear? Here in the case of decimal, it is 10 to the power n. Okay, so generalized formula is r to the power n small n minus n. Here r it will be the base. Clear? Understood so far? Any
Yes, ma'am.
problem?
Yes, ma'am.
No. No, right. Then, for example, let's say, so if you are supposed to find the two's complement of a given number. Okay, so here you have 10110000. So how many digits you have? 1, 2, 3, 4, 5, 6, 7. So 2 to the power 7 minus this number. Clear? So now 2 to the power 7 is what? 128. Clear? So whatever the thing, 2 to the power 7 minus this number, the formula will be, now 2 to the power 7 is 128. You cannot subtract 128 minus a binary number. So whatever the value 2 to the power 7 you get, it will be written in the form of binary representation, and then you will subtract it. Clear?
No, ma'am.
Now see here, this is for decimal number. Okay, now in the case of binary number, if it is binary, then it will be called as the, okay, what happened? Now here you have for r equals to 2, that is for binary. Okay, now the general formula will be r to the power n minus n. Okay, so this is a generalized formula for finding r's complement. General formula. Clear? So if r equal to 10, that is a decimal number, it will be 10 to the power n minus 1. If r equal to 2, it will be 2 to the power n minus 1 and minus n. Understood so far? This is the formula. Okay. Understood? Yes or no so far?
Yes, ma'am.
Now, if in the question, if the value of n, the given question is, let's say 1001. Okay. So here, the value of small n will be what? What will be a small value of n? N is the number of digits.
I am trying to solve.
Yes. Any problem? Guys, respond. Yes or no at least. What will be the small value of n out here? How many digits are here? In this n, 1001, binary
Hello?
number, 4, right? So n will be 4 out here. Now let's apply the formula r to the power n
Yes, ma'am.
minus n. Here r equal to 2, so the formula is 2 to the power n minus n. Okay, so to find, now it will be called 2's complement. 2's complement of n equals to the power n minus n. Okay, so it will be equals to what? 2 to the power, no, 2 to the power what? What is the power? 4. Okay, right, minus minus n is what? 1001. Now this number is binary representation. It's not 1001. Okay, this is binary. Clear? So this is binary. So what is 2 to the power 4? 16. Right. So this 16 is decimal number. So this 16 is a decimal representation minus what?
Ma'am,
1001. Yes. Yes, tell me. Anyone? Did anyone ask question?
no, ma'am.
Okay, so this is 16 is in base 2 to the power 4 is 16, right? So this is in base 10, base 10 decimal, and this is in binary. So you cannot subtract two numbers in different number systems or in different bases, right? So you need to convert either this decimal into binary or this binary into decimal. You need to convert it first. But since the question we are out here, we are dealing with binary numbers. So let's convert this decimal into binary. Clear? So what will be 2 to the power? What will be there? 16 represented in binary. What will be the value? 1000.
1, 2, 4, 8, 8 got 16. Yeah, 1.
Yeah. 10000. Right.
Yes, ma'am. 4 कुछ 4 0 और उसके बाद
Yeah.
1.
Four zeros, then one. Right.
Yes, ma'am.
So you will subtract now
1
and yes. So whatever the value you get out here, it will be
1
it will be
8.
the two's complement of this n. Understood? Yes or no? Now again, if the question of n equals to 100.11, now what will be the small value of n out here? What will be the number of digits?
3
3. Yes, we will be counting only the non-fractional part. Now,
into
so after that you will give, yeah, for this question, 2's complement of n equal to this, so 2 to the power 3. 2 to the power 3 minus this n. Okay, so 2 to the power 3 is
8,
8.
ma'am.
Yeah, 8
8
is
का 10
decimal.
नंबर हो जाएगा.
8 minus 100.11. So 8 is a decimal number. So you need to
2
convert it into, so
1 triple 0.
yeah, so you will subtract this, and whatever result you get, that will be the 2's complement of this number. Understood so far?
Yes, ma'am.
And then Ansul Pransul, understood, yes or no? Ansul Pransul, are you there?
Yes, ma'am.
Yeah, respond when I ask questions. You respond at least whether you are understanding or not. Okay, this is very important. Okay, you need to be able to find complement of numbers. Okay, only after that you will be able to know subtraction in computers, how the subtraction process is being performed. Okay, now this is about R's complement. Now I have just told you there are two form of complements. One is called as the R's complement and another is called as the R minus 1's complement. Right. So, where is that? So we have done up to R's complement, that is 10's complement, 2's complement. You can even find 8's complement, hexa, okay, then a 16's complement and so on for any base. But for our syllabus, we will be focusing only on tens complement and twos complement. Now that is for twos
Okay.
complement. Okay. Now we have a quicker method or a shortcut method for finding twos complement. Okay. So let's see how do you find it easily. Method 1, there are two. Okay, the two's complement of a binary number is obtained by adding 1 to the ones complement value. We haven't learned how to find ones complement. Okay, but after you learn it, okay, first you find the, just a second. Okay,
Okay.
okay, so where is it? Okay, so another way of finding two's complement is to find the ones complement of that number and then you add a 1 to that number. Okay, so that is just the method. Remember the method, okay? We will be learning how to find ones complement. So if you are given a number, let's say a number like this, and if you want to find the two's complement of this number, you first find ones complement, okay, and then you add a 1 to that value whatever you get. Okay, if this is the ones complement that you get, then you add a 1 to this, then whatever the result you get, it is called, it is the two's complement. Clear? So you can find by using this method or the previous method, 2 to the power n minus n formula. Okay, so this is another way.
Okay.
Yeah, so this is one way. One's complement we will be discussing right now. Another method of finding two's complement, okay, is 2 can be formed by leaving all least significant zeros and the first one unchanged and then replacing 1 by zeros and zeros by ones in all other higher significant bits. Okay, so here, suppose let's say you are supposed to find a 2's complement of this number 1 1 0 1 1 0 0. So if this is a value of n, capital N, you want to find a 2's complement of this number. Okay, so what does it means? Two consonants can be formed by leaving all least significant zeros. Okay, least significant means the rightmost ones. So wherever there are zeros in the rightmost side, whatever there are zeros, okay,
Oh,
counting the right hand side, you just leave as it is. 1 0 0. Okay, so 0 0, the two one you just left it as it is. Okay, and the first one unchanged. Okay, so starting from the right hand side, the least significant, you start looking whether there are zeros or not. So as long as there are zeros, you just keep on as it is. Okay, the first time you
okay,
encounter
ma'am.
the first time you encounter a one, that one also you keep unchanged. Clear? That one also you keep unchanged. After that, the first one you encounter, you keep it unchanged. After that, wherever there are ones, you replace by zeros. Wherever there are zeros, you replace by one.
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 Yes. So that is how you find two's complement. This is one method. This is another method to one by using one's complement, and another method is by using the actual formula. Okay, whatever is easier for you, you can do it. Okay, so let's
Okay.
take one
Okay,
example.
ma'am.
Yeah, so let's take one example of, forget about the two's complement one. I mean, forget about find using one's complement. Okay, let's take a simple example. So for this question, okay, so you can find out by subtracting from this number, okay, or else if I find, let's say, if you want to find the two's complement of this number, okay, so by the rule two's complement, it is written as you start from the right hand side, the least significant one. Wherever there are zeros, you keep as it is. So here there is no zeros, okay. So nothing to write. So and you just say for the first one that you encounter, this is the first one that you encounter. So you keep that 1 as it is. Okay. After that, wherever there are zeros, you keep 1. So you write 1 1. Sorry, not here. So 1 1. Okay. For these two zeros, you keep 1 1, and for this 1, you keep
zero,
a 0. So
zero.
this is the answer that you get, or this is answer for 2's complement of this n. Clear?
Yes, ma'am.
So for here another n I will give. So if you are given a big number n, 1 0 0 0 0 0 1 1 1 0 0 0. So if you want to find, let's say if you want to find the 2's complement of this n, okay, just by looking you can easily find out 2's complement of n equals to, you start from the right hand side. Okay, so as long there are zeros, you keep as it is until you encounter
Zero.
a first one, right? So this 1 0 0 you will keep as it is. Okay, so you will, let's
Okay.
keep as it is. Okay, after that whatever there are, so this section, okay, wherever
Zero.
there are zeros you put 1 instead of that, wherever there are ones you put 0 instead of that. So
Zero.
here, so this 1 0 0, you will not be changing. So the rest will be reversing. Okay, so there is a 1 out here. Okay, the first is a 1, so you write 0. Then
Zero.
we have,
One.
how many zeros out here? 1 2 3 4 5 6 7 8 zeros. So you will be
Seven.
writing 1 2 3 4 5 6 7 8. Okay, then you have a 1 out here, so it will be 0.
Zero.
Yeah, not here.
Zero.
0. And then how many? 1 2 3 4 5 zeros. So
Five.
again 1 2 3 4 5 ones, and then 1 1. Okay, so not 1, yeah, 1 1. So it will be 0
Zero.
0.
Zero.
Okay, then 0 0 again. It will be 1 1. And then a final 1 out here. So it will be a 0.
Zero.
Yeah. So you just combine them. Okay, now this is the 2's complement of this given value of n. Understood?
Yes, ma'am.
Okay, so this is one way. Now another way is to find first the 2's complement of a 1's complement of a number, and then finding the adding a 1. Okay, like this another, the first method we will do when we do the one, find the 1's complement. So far we are done. We have done with one. We are done with R's complement. Anyone having issues or anyone having doubts, we can do it right now. Ansul, Pransul, Gulshan,
No, ma'am.
regarding
No doubt.
regarding R's complement. No doubt, right?
Yes, ma'am. No doubt.
Okay, now let's discuss R minus 1's complement. So if you are given a number n, okay, in base R having n digits, the formula, the thing is same, n is a number, R is the base, small n is the number of digits. The R minus 1's complement of this capital N is defined by R to the power n minus 1, okay, then minus n. So in the previous R's complement uses R to the power n minus n. Okay, here it is, there involves a minus 1. That's why,
Ma'am, not.
what?
Ma'am, your screen not visible. Not.
Wait. Can you see it now?
Yes, ma'am.
Yes, ma'am.
Okay, so here in the formula in the previous R's complement you have R to the power n minus n. Okay, there is no minus 1 involved. Here we have an extra minus 1. Okay, that's why the name R minus 1's complement. Okay, so the only addition we have here is R to the power n minus 1. Okay, so this is the only addition we have here. Okay, so R minus 1's complement is then it will be called as the R minus 1, that is 9's complement. And if R equals to 2 for binary numbers, it will be 2 minus 1, that is 1. So it will be called as the 1's complement. of that number. Clear? So let's come to the formula. So for decimal number, r equal to 10 and r minus 1 equal to 9, and therefore the name will be called as the 9th complement of n, and will be given by the formula 10 to the power n minus 1 minus the number.
And
Okay, so you just remember the formula. Now coming to 9th complement. Suppose you are given a number n. Okay, this is the formula. Now if you are given a number n 546700, okay, if this is the value of n, capital N, to find a 9th complement, what you do is you subtract each digit from 9. Why so? Because 10 to the power, how many digits are here? 1 2 3 4 5 6. 10 to the power 6 is, there will be 6 zeros. Okay, 10 to the power 6 zeros minus 1 is 99999. This is what you get from 10 to the power 6 minus 1. Okay, then you subtract the value of the number. So simply put, if you want to find a 9th complement of a number, okay, you just subtract each digit. You just subtract each digit from 9. Clear? Easy.
Yes, ma'am. Yes, ma'am.
Okay. Yeah, so this is for 9th complement. You just subtract each digit from 9. Okay.
Okay, ma'am.
Now if you want to find the uh, wait a minute. Okay, if you want to find the for binary number, okay, r is equal to 2, so 2 minus 1 is 1, so it will be called as the 1's complement. Clear? So r minus 1 is a 1's complement, so 1's complement of the value of n is, the formula is same, 2 to the power n minus 1 minus n. Here n is the number of digits, so if you have an example, okay, so 2 to the power n minus 1 minus n. Okay, so 2 to the power n minus 1 is this. Okay, so here we have how many digits? 1 2 3 4 5 6 7. Okay, so you are going to subtract each of these digits from 1 1 1 1 1. Okay, so I will tell you a simple example or how to find our 1's complement. You can perform normal. 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 0 is 1, 1 1 minus 0. You just apply the formula. You can do like this. Okay, another simpler method to find 1's
okay, ma'am.
complement is uh, okay, let's do 1's complement. 1's complement means whatever the value that will be given will be in the form of binary, right? So let's say n equals to 1010, something like this. So if you want to find the 1's complement of a given number n, it is very easy. 1's complement of, okay, 1's complement of this n will be, you just replace 0 by 1 and 1 by 0. Okay, so here wherever there are 1 you put zeros, wherever there are 0 it will be 1. So it will be, here it will be 0 1 0 1 0 1 0 1 0 1 0. Understood?
Yes, ma'am.
Now if the value of n equals to 1 0 0 0, what is the complement? What is the 1's complement?
0 triple 1.
0 triple 1.
Hello.
Yes. Now if the value of n equals to 1 1 1 1, then the value of 1's complement will be
Quarter 0.
0 0.
Ansul Pransul, understood so far?
Yes, ma'am.
Yes, ma'am.
Yeah, okay, so this is about r's complement is very easy. Okay, and if n is a decimal number, suppose let's say n is 98564, something like this. Okay, so here it will be called as the 9's complement. Okay, 9's complement. So 9's complement will be, just subtract How many digits are there? 1, 2, 3, 4, 5. So you just write 5, 9. 1, 2, 3, 4, 5, 9. 9, 5 nines minus 9, 8, 5, 6, 4.
Yes.
Clear?
Yes.
So this is very easy. Now we have discussed in our this previous slide finding 2's complement by using 1's complement. Remember? This is about where is it? Yeah, the first one. See here, the 2's complement of a binary number is obtained by adding 1 to the 1's complement value. Right? So you can find 2's complement of a number by using 1's complement also. Clear? So suppose let's say what a question out here in the previous question, 2's complement, 2's complement. Okay. Now the value of, see here, for this n. Okay. B. N is here. We have already find the 2's complement of n by using the second method, right? By
Yes.
putting all the least significant zeros unchanged and the first one unchanged and exchanging all zeros and ones, right?
Yes, ma'am.
So
Yes, ma'am.
this is one method. Suppose let's take another example. For n equals to 1, 0, 0, 1, 0. Okay, so let's find by using 1's complement. Okay, so by the formula, by the step mentioned, it has been given when I first find the 1's complement of this n. Okay, before doing that, let's find 2's complement by using this method, control C. Okay, 2's complement of one method is, this is method number 2.
Oh.
Okay, we have already method, by method number 2's complement of n is, you just put this 0 and this 1 unchanged, right? The least significant 0, all zeros unchanged, and the first one unchanged, and then you exchange all zeros and ones, right? So
Zero
it will
double one.
be 0, 1, 1, then 1, 0. This is the answer for this 2's complement of n, right?
Yes.
Now another method we have is, the first method we have discussed is, first find 1's complement. Okay, so let's find 1's complement of n. Here n equals to this. Okay, so 1's complement of n is, how do you find 1's complement?
Zero double one, zero one.
Yeah, yeah, so exchange 0 and 1. Okay, so it will be 0, 1,
Double
1,
one.
0, 1.
One.
One.
Okay, now to
Now
find,
done.
now 2's
The
complement.
yes.
2's complement you get is,
Now add one.
yeah, 1's complement
One.
of n. The formula is 1's complement of n plus 1,
And
right?
One one
So
is
it's,
equal to जाएगा
yeah,
zero.
yeah, so this is answer, 1's complement of n
one.
plus 1, plus 1. Okay, so you perform binary addition. 1 plus 1 is
Zero.
1. 1 plus 1 is 0 with a carry
Zero.
1,
One.
right? So that 1, this 0 you add, you
One
get
plus zero is one.
1 plus 0 is 1. Okay, then rest will be 0, 0, 0, right? So it will
Yes, ma'am.
be 0,
Yes, sir.
0, 1, 1. So the, oh, something is wrong.
Yes, ma'am.
1 plus 1 is 0. Oh, here I have by mistake written that the value of n is
Carry one
the
जाएगा ना.
first, it should be 1, 0, right? The first, oh, not here, not here.
One.
Here and this two should be same. Now we have find the same answer. Clear? Understood? Yes or no?
Yes, ma'am.
One method
I,
is through this, another method is through this. So whatever is easier, you can use any of them. Understood?
Yes ma'am.
Okay, now for today we'll be discussing only complement. Clear? tomorrow we'll be doing subtraction using these complements. There are again two subtraction by one by using r's complement and another by using r minus 1's complement. Okay, so we'll be doing that later on. Okay, so practice with these examples. Okay, find r's and r minus 1's complement of the following. Okay, the number will be 2 3 4 5. Okay, then 2709.45 0.567. Okay, this is for decimal number. Okay, then for binary, let's say 110.11.0.00.1. Okay, that's another a 11111 So this going 1101. Okay, this is the question. Practice.
Okay, ma'am.
Have you copied?
Yes.
Yes, ma'am.
Yeah, I will not be saving this space. Okay, so now in yesterday's class, previous class, we have done conversion from one number to another, right?
Yes.
Decimals, everything. I forgot to tell one thing. Okay, now when you convert, yeah, now when you convert from what to say binary to octal or binary to hexadecimal, there is a shorter way. Suppose let's say this is some binary number. Okay, this is some binary number. Now you want to convert it into octal or hexadecimal. Okay, this is binary. Now you want to find the octal equivalent. Okay, so what is the octal equivalent of this number and another hexadecimal equivalent? Okay, so that there is a shorter way to do so. So first, if you want to convert it into octal, let's discuss about octal first. Okay, the same number, let's say. Okay, now for this question, if you want to convert this number into octal, okay, so another shortcut method is you start from the least significant bit. Least significant bit is the utmost bit. Okay, you start from the least significant bit and group by 3.
Two, three.
Group by 3 bits. Why 3 bits? Because 8 is equals to, for 8 it is equal to 2 to the power, how many powers equal to 3? 2 to the power 3 is equals to 8,
Three.
right?
Yes, ma'am.
2 to the power 3 is equals to 8. So this 3, okay, this power, so this will be taken. So you try to group by 3 bits, but remember you should start from the least significant bit. Clear?
Okay,
So
ma'am.
you start from that much side, you try to group by 3. 1 2 3.
Three.
Okay, you have grouped this. Now again 1 2 3, 1 2 3, 1 2 3, 1 2 3, 1 2 3, 1 2 3, 1 2 3, 1 2 3. Now you are left with a single bit, no grouping, right? Then for this you
Yes.
need to add 2 extra zeros
Zero.
on the
Two zero.
leftmost.
Yes, ma'am.
When you cannot group, okay, you just add. Now
Yes, ma'am.
what to do, the next step is you write the decimal equivalent, not decimal, the octal equivalent. Okay, since we are doing with octal number, so you write the octal equivalent of this 3 bits grouping. So 001 is what?
001.
1. So you write 1. 0, 0, 0 is
Zero.
0. 0, 0,
0,
1 is
One.
1.
1,
Then 0, 1, 0 is
Two.
2. 0, 1, 0, 2. 1, 0, 0, 4. Right.
Four. Yes.
Then 1, 0, 1 is
101 is equal
5,
to 3.
5.
5,
Right.
02 1 2 4. 4 1 plus 1 5.
5, ma'am.
Yeah. So the 0, 1, 1 is
3,
3
3. 0, 1, 0 is
2, ma'am.
2.
2.
Right. So now this is the octal equivalent of the given binary number. Binary number. Understood?
Yes, ma'am.
Yes, ma'am.
Yeah. So this is one shortcut method. Now, if you want to find a decimal, hexadecimal equivalent, the same number, okay, hexadecimal equivalent.
2 to power 4 and 4 bits.
Yeah, 4 bits. You have to group by
4,
4 bits. So you start from the least significant bit. 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now here proper grouping is there, so no need to add extra zeros. Okay. Now
yes, ma'am.
you write the hexadecimal equivalent. 1 0 0 0. What is this?
1 2 4
8,
8 8.
8.
8, ma'am.
Yes. So 0 1 0
2
0 1 0 is
2, ma'am.
2.
2,
1 0 1 0
2
10,
4 8
10. How will 10 be written? It will be
8
A.
A.
Yeah. 1 0 1 0 again. A.
1, 10,
1
ma'am.
0 0 1. What is this?
Yeah,
9,
1.
9, D,
9.
D,
Yes.
ma'am.
Then 0 1 0 1. What is this?
5.
5,
5.
ma'am. 5,
1 0 1 0. What is this? Again? A.
9, 9,
9.
9. Yeah. 9.
10, 10, 10,
No, it is 10.
10,
This,
ma'am. 10, ma'am.
yeah, so A. 10 will be written as A. So this is the hexadecimal equivalent of this binary number. Easy.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now this is for binary number without any fractional points. Okay, for fractional point, you start from the least significant bit and that is the rightmost side to and move towards the leftmost bit. That is the right to left. Okay,
Okay.
now if your number has both fractional and non-fractional part, let's say 0 1 1 0 something something like this, dot 1 1 0 something like this. Okay, then how do you group by 3? Okay, you cannot start from here. Okay, so you group for the non-fractional part if it is for octal conversion. Okay, if it is for octal conversion, the same thing grouping by 3 will happen, but for this what will happen, you start just before the decimal point, 1 2 3, same as before. Start from the
Yes, ma'am.
rightmost, that is least significant bit. Okay, 1 2 3. Then for this 0,
Already zeros.
you decimal point, you start from here, not from the leftmost side, because
Yes,
this is the least significant. Okay,
okay.
clear? You proceed from
Yes,
this
ma'am.
side, 1 1 0 1 0
0,
0.
8.
0. Okay.
Yes, ma'am.
Okay, ma'am.
Yes,
After
ma'am.
that, after that, whatever you write, you get the same thing process. You just have to check for the direction. For the non-fractional part, you proceed from right to left. For the fractional part, you proceed from left to right. Clear?
Yes.
Okay, ma'am.
Okay, for
Yes, ma'am.
today, yeah, for today this much. Practice with the thing I have given, how to find one's complement, two's complement. Here I have written both r's complement and r minus 1. So for this decimal number, you have to find both the tens complement and nines complement. For this binary section, you have to find both two's complement and one's complement. Okay? Okay.
Yes, ma'am.
Practice it, because in the next class we will be doing subtraction, and in that we will be doing both, like we will be involving both these complements, r's and r minus 1. It's not that difficult. So for today, let's wind up out here. I hope no one is having any doubts.
No, ma'am.
No, ma'am.
Okay, okay then.
No, ma'am.
Bye everyone.